Hello folks, we come to the part 1 video of this exercise 3.4, and this is a totally new concept where we are going to learn how to find the inverse of a given matrix by using row column operations. So there is a tailor-made format in which it has to be done, so we will be doing it like this. Whenever we start this matrix, we will call the given matrix as A, and whenever we are using row transformation, we will use the equation A equal to IA, and whenever you are using column operations, you will use the equation A equal to AI. Invariably in our videos we will be using row operations, so we will be using A equal to IA, and that way we will be proceeding. Alright, so first of all, let's call this matrix as A. Let A be this matrix. Also let A be equal to IA. As I said, whenever we are using row operation, we should use this equation. If you are planning to use column operations, then you should use A equal to AI. Whatever you are comfortable with, you can use that. But throughout the problem, you can use only one. Either you use row operation or you use column. You cannot mix both. Okay. So that's as per your convenience. You can take up any one, but throughout you have to maintain one thing, either row or column. Okay. Now, to proceed with, A for us is 1, minus 1, 2, 3, and I, it's a 2 cross 2, so I is this A, you can keep it as it is. Now what we are going to do is, our strategy is going to be such that we are going to transform this matrix and make it this matrix. That means over the period of time, this side should become 1, 0, 0, 1. Okay, so this matrix will change into something, and that something will be A inverse. Okay, because it's an equation, whatever transformation we do on this side, we have to do it on the other side also. So like that, we'll keep on doing elementary row column transformations, row transformations on both sides, and like that we will be able to get the inverse. That is roughly going to be our strategy. As we do it, it will be more clear. Let's check how. Okay, now whenever we are doing row column operations, there is another strategy that how you have to proceed. First, you make this entry 1. That is your first step. Second step is to make this entry 0. This is the first step. This is the second step. Third step is to make this entry 1. And the fourth step is to make this entry 0. That is going to be a step. That's how you are going to move stepwise. So, our first step is to make this entry 1, which is already there. So, our first step is over. Now, second step is to make this entry 0. So, that is our next step. How will this entry become 0? This entry will become 0 if you get 2 minus 2. So, somehow you have to get a 2 from somewhere. And you are supposed to use this matrix alone. You cannot bring things from outside. That is why we are using row transformations. So, what we will do is, we will change R2 by the transformation R2 minus 2. How you get the 2? 2 into R1. How? If you multiply 2 by this, it will become 2. Like that, you will get 2 minus 2. Right? So, what will happen here? First column will remain, first row will remain as it is. But in the second row is what is changing. R2 minus 2 R1. 2 into this entry is 2. So, 2 minus 2, 0. Then 2 into this entry is minus 2. So, 3 minus of minus 2. Can you see it? Yeah? What we are going to do is R2 entry, whatever is there, R2 minus 2 into R1. So 2 into R1, here the entry is minus 1. So it's minus of minus 2. It will become 3 plus 2, 5. Same way here. First R1 you don't have to be bothered, it will be as it is. But R2 you have to multiply 2 here. So it will become 2 and subtract. So it will become minus 2. Here because it's 0, it will not change. Now, we've got this, we've got this. Step 1 and step 2 is over. Step 3 is to bring this 1 here. Bringing 1 here is difficult because of the kind of entries here. So, directly we will divide by 5. Okay, and make it 1. So, what we will do is in the next transformation, R2, we are going to divide throughout R2 by 5. What is the advantage? We will get 1 minus 1, 0, 1. And what is it over here? Minus 2 by 5, 1 by 5, because R2 both sides we are dividing it by 5. So first step is over, second step is over, third step is over. Next step is to get 0 here. Now how can you get a 0 here? If you get a plus 1 only, and that you can easily get from here, right? So next transformation is R1 becoming R1 plus R2. What is the advantage? This will get added up, it will become 0. So here you got the identity. What we are doing, R1 plus R2. That means we are doing 1 minus 2 by 5 and 0 plus 1 by 5. Right? Minus 2 by 5, 1 by 5a. So see what we have got here is I equal to 1 minus 2 by 5. Imagine it is into 5 into 5. 5 minus 2 by 5, 3 by 5. 3 by 5, 1 by 5, then minus 2 by 5 and 1 by 5a. So a into a inverse is I. By that logic, you will get the inverse. A inverse is 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. That's how we get the inverse. And this is how it's a 2 cross 2 is much easier. When it is a 3 cross 3, because the steps are more, you'll have to be doing more work. Yeah. Same way here, let's get across. Let's call this as A. Okay, and next step, also let A be equal to IA, IA, and A for us is 2111, this is 1001A, right? This has to be 1, that's our first step, but it is 2. So if you do 2 minus 1, you get it, isn't it? So first we will change R1. How? R1 minus R2. So what will happen? This will become minus 1. This will also become minus 1. So what will come here? 1, 0, 1 as it is. Minus R2. So minus 1, 0, 1, 8. This is R1 minus R2. The corresponding entries, they have to subtract. Then, so you are done with this. Now this has to become 0. Okay, second step is to make this 0. That if you do 1 minus 1, it will become 0, right? So R2 will become R2 minus R1. Check what is happening. 1, 0, 1 minus 1, 0, and 1 here. Here it is R2 minus R1, minus 1 plus 1. So this will be minus 1, this is 2. This has got converted, by default it has got converted into an identity matrix. So what has happened, therefore I equal to A inverse into A, and that A inverse for us is 1 minus 1 minus 1, 2. Yeah. So because it has come little readily, let's take the third problem also. 1, 3, 2, 7. Right. Also let alright, the standard step. This is okay, right? Your first step is done. Second step has to be 0. So you have to have 2 minus 2. For getting the 2, we are going to use R1 and we are going to do R1 minus 2R2. So R2 becomes R2 minus 2R1. What happens? 1, 3. This will be 2 minus 2. We have to do into 2 here. So into 2 is 6. 7 minus 6. What will come? This will be 0. This will be 1. Oh, right away you got that done by default. So what will happen here? 1, 0. R2 is 2R1. So minus 2. This won't change. Minus 2, 1, 8. Right. Now this has to become 0. So if it has to become 0, it has to become 3 minus 3. And from where you get it? You get it from here. R1 is becoming R1 minus 3R2. So see how much is this? 1, 0, 0, 1 right away. And here R1 minus 3R2. So 1 minus 3 into minus 2. So that's minus 6. And 0 minus 3. So this is 7. 1 plus 6. And this is minus 3. Minus 2. 1. 8. Yeah. So therefore A inverse is 7 minus 3 minus 2. So this is how we get across doing the inverses of the matrix. There is a step-by-step procedure by which it's a voluminous exercise, so many problems. Step-by-step idea by which you are supposed to be doing it. How we have done it. There are more problems that we'll be taking it up in the next video. Thank you.